Good morning and welcome to the lecture on numerical methods. Today we are going to discuss regular falsi method in order to find real roots of nonlinear equations. The formula is x is equal to a f of b minus b f of a by f of b minus f of a. Note, if a and b are close enough, we can obtain the approximate roots quickly. Example, compute the real root of the equation x log x to base 10 equal to 1.2 correct to 4 decimal places. Solution, let f of x is x log x to base 10 minus 1.2. First, we need to determine the values of x which are close, and we get a negative and a positive value by trial and error method. When we put x is equals to 0, we get f of 0 equals to 0. When we put x is 1, f of 1 is minus 1.2, f of 2 minus 0.6, f of 3 0.23, which is positive. So the root is lying between 2 and 3 as f of 2 is negative and f of 3 is positive. Now let us come closer to the 2 points so that once again we get a negative and a positive values. Let us start from f of 2.1, 2.2, 3, etc. till we get a negative and a positive value successively, which we can observe here. It is happening for 2.7, which is negative, and 2.8, which is positive. Hence, the root lies between 2.7 and 2.8. Now, after getting the interval, let us start the first iteration by choosing a as 2.7 and b as 2.8. When we compute f of a, we are getting minus 0.0353 and f of b is 0.0520. x1 is given by the formula, and on substituting the appropriate values of a, b, f of a and f of b, we get the value of x1 as 2.7404, which on substitution to the equation, we are getting f of 2.7404 is a negative value, that is minus 0.00021. So in the iteration 2, we replace the old value, that is 2.7 with 2.7404. Then a is 2.7404 and b is 2.8. In the same procedure, we will compute x2 on getting 2.7406. Now we can observe the difference between x1 and x2 exactly 3 decimal places. It repeats the same. So f of x2 is given by a negative value again. So old value of a is again replaced with a new value, that is 2.7406. Hence the root lies between 2.7406 and 2.8. So f of a is negative and f of b is positive. So x3 is computed by using the new values. We get 2.740646. The approximate root is 2.7406 because the previous value is also 2.7406. Up to 4 decimal places it repeats, hence we can stop this. Let's go to the next example. Using the regular falsi method to find a real root of equation x cube minus 2x minus 5 equal to 0, correct to 3 decimal places. Let us assume f of x as x cube minus 2x minus 5. So again by trial and error method, we will substitute the values of x as 0, 1, 2, 3, etc. till we get successive values, a negative and a positive, which we are getting it for 2 and 3 because f of 2 is negative and f of 3 is positive. Hence the root lies between 2, 3. And now f of 2.1 is 0.061, which is positive, and f of 2 was negative. Hence the root lies in the interval 2 and 2.1. The first iteration, let us choose a as 1 and b as 2.1. As we have already computed f of a and f of b, substitute in order to find the value of x1 in the formula. That gives x1 as 2.0943. But f of x1 is negative. In the second iteration, again we are choosing a as 2.0943 and b as 2.1 and compute x2 value, that gives us 2.0946. As per the requirement in the question, they have asked for 3 decimal places. Therefore, the required approximate root is x is equal to 2.094. Here are some of the sample problems for the practice. First one is find the real root of the equation cos x equal to 3x minus 1. Correct to 3 decimal places. Answer is given. Similarly, the second problem, to find the fourth root of 12, correct to 3 decimal places by using regular falsi method. Hint is x is equal to fourth root of 12 and the answer is given for both the problems. One more note I would like to give here is, whenever we are taking a trigonometric function, take the calculator and put it in the radian mode. That gives the values. One more problem. Find the root of the equation x cube minus 4x minus 9 equal to 0. The answer is given up to 3 decimal places. Thank you.